Welcome to Aviation Republic. North American Aviation's often forgotten F-107A remains perhaps the most enigmatic of the famous early century series fighters. The enigma stems from the fact that it was an outstanding and extraordinarily effective warplane, and was, perhaps, the best jet in the world for its particular job at the time of its first flight in 1956. Mysteriously, it was never to go into production, even in light of its superior capabilities. The F-107A scored several firsts. Among them were a truly unique flight control system, an advanced inlet system, and the incorporation of a semi-submerged store, a rocket-powered vertical launch system. But it would also be the last of a long line of famous North American aviation fighters, which included the legendary P-51 Mustang and the magnificent F-86 Sabre to be built. The design of this jet divides many aviation enthusiasts. Some would call it ugly, and some would say it is quite pretty. It is nevertheless certainly radical. Undoubtedly, its most outstanding feature is its very distinguishing unconventional dorsal-mounted inlet duct. How it got there is a tale of ingenuity and necessity. The story of the F-107A Ultra Sabre, also known as the Super Sabre, or simply, to those who flew her, the Man-Eater, began in 1952 when North American Aviation tasked its design team with conducting an engineering study to create an advanced Mach 2 tactical fighter and nuclear-capable bomber. Because in the 1950s, nearly every service, except for the Boy Scouts, sought nuclear strike capabilities, which at the time was provided by the F-84 Thunderjet and F-100 Super Sabre. However, North America also envisioned their new jet being capable of being rocket-launched almost vertically from a mobile platform, but more on this later on. But rather than starting from scratch, the design team decided that they would use their extremely successful F-100 Super Sabre as the base for its study. Initially, the proposed design was designated as the F-100B and was planned to be a faster version of the F-100, which was, by the way, the first USAF aircraft to fly supersonic in level flight, and optimize it to maximize the power offered by the J-57 jet engine, while keeping the original swept-wing platform of the F-100 Super Sabre. At the same time as designing the F-100B, North America started to study the possibility of adapting the F-100 Super Sabre as an all-weather interceptor, naming the project the F-100I. The I for interceptor, also sometimes referred to as the F-100BI. However, at this point, none of these were official USAF designation. In October 1953, North American designated the project NA-212 and began wind tunnel testing, with work starting on a full fighter-bomber aircraft mock-up. Even so, neither the F-100B nor the F-100BI interceptor attracted much interest from the USAF. Consequently, in January 1954, due to the lack of interest from the Air Force, they decided to abandon plans to undertake full production, and the program was scaled back to a comprehensive engineering study. But luck would have it, only a few months later, in April 1954, they heard that the Air Force was interested in the fighter-bomber configuration of the NA-212. In particular, they were interested in an aircraft capable of Mach 2 and able to carry the Mach 7 nuclear gravity bomb, which they considered critical to national defense. In May 1954, North American directed that all work on the F-100B interceptor project be terminated and that all efforts now be concentrated on the F-100B fighter-bomber adaptation. In June 1954, the USAF awarded North American a contract for 3 prototype F-100B fighter bombers, and only a month later, they notified the company that the project designation had been officially changed to F-107A, since they concluded that the new aircraft would be so vastly different from the original F-100A that it deserved a completely new fighter designation. While the F-107A has often been referred to in print as the Ultra Sabre, the Ultimate Sabre, Super Sabre, or such, it was never officially assigned a nickname. North American Aviation's TAC fighter bomber candidate was simply known as the F-107A. Let's discuss that radical dorsal air intake. The Air Force requirement called for the design to be capable of carrying a strategic nuclear bomb. In the 1950s, nukes were not small, and to carry the payload, the underbelly would need a large, semi-recessed weapons bay, a kind of belly pouch that would half-cradle a tactical fission bomb. It has been claimed that early on in the wind tunnel tests, it was discovered that there would be major issues with weapon release and separation caused by airflow interference from the nose radome and chin air intake. A chin intake which, in the original design, was similar to the air intake on the Vought F-8 Crusader. To correct this problem, the air intake was moved from the nose to the top of the fuselage, just behind the cockpit. Although it is more likely that the intake was positioned on the dorsal, since a conventional nose inlet would have required an internal air duct that would interfere with the centerline weapon station. Even though the wing root intakes that bracketed the bomb might have worked, North American must have thought the dorsal turret straight back to the engine just looked cooler. And they weren't wrong. The air intake, or to use its correct name, the Dorsal Mounted Variable Area Inlet Duct, or just VAID, was unique to the F-107A at the time, and is today considered an early form of variable geometry duct. What made this intake special was that it fitted a complex system of variable inlet ramps to allow for optimal airflow to the engine at various speeds. The VAID system proved very efficient, and North American Aviation used the design concept on its A-5 Vigilante, XB-70 Valkyrie, and XF-108 Rapier designs. For the initial flight tests, the first two prototypes were fitted with a two-position engine inlet duct system. This system incorporated a vertical wedge-shaped splitter in the middle of the intake, with 4 hydraulically powered doors attached to the sides of the wedge inside the intake. The doors would extend or contract as needed to adjust the intake throat area for optimal airflow to the engine. In the third prototype, the system was made fully automatic, and the doors were continuously adjustable. Although the intake severely limited rear visibility, it was not considered important for a tactical fighter-bomber aircraft, since the assumption was that dogfighting with guns was a thing of the past, and that any future air combat would be via guided missiles outside visual range. Even so, pilots were justified in their detestation of the idea of being unable to see behind them. However, this is contradicted by the fact that the second prototype was fitted with multiple cannons.
I hope you're enjoying this video as much as I've enjoyed making it. A lot of time and effort went into researching this video, and I'd appreciate it if you could take a moment to hit the like button to feed the YouTube algorithm. This helps the channel grow and reach more people, and perhaps you'll consider subscribing for more aviation content. Now, back to the video.
Due to the unusual location of the air intake, the one-piece canopy opened straight up rather than sliding back or opening in the usual clamshell fashion. Although the canopy could be separated from the aircraft in an emergency, the pilot could also eject right through the canopy without having to jettison it first. Even so, tests carried out on the ejection system appear to have been only carried out on the ground using dummies, not while the plane was in the air at high speed. And therefore, pilots were uncertain that upon ejection, they wouldn't be sucked into the intake or impaled upon it. So, it's no surprise that the pilots who flew the F-107A called her the Man-Eater. Keep in mind that ejection systems technology was still developing in the 1950s, and test pilots had to hope that they were not going to be sucked up into the J-75 engine if they had to abandon the aircraft, which fortunately they never had to do in anger. The designers also redesigned the vertical tail, using a single-piece, all-moving slab instead of a rudder for directional control. This innovation was adopted for the A-5 Vigilante, with longitudinal control provided by an all-flying horizontal tail. A complex spoiler slot deflector system on the wings provided lateral control. The wing leading edge was similar to that of the F-100A and had automatically actuated slats, but the wing trailing edge was made up entirely of tabbed and slotted flaps. There were no ailerons. Lateral control was provided by a set of spoilers, or spoilerons, above and below the wing, which permitted the aircraft to maintain roll authority at supersonic speeds. The aircraft was also equipped with an early fly-by-wire control system known as the Augmented Longitudinal Control System, or ALCS, that used air data system inputs to provide a command of pitch and rate. The jet was to be equipped with the company's Autonetics Division XMA-12 integrated fire control system in the nose. This system could detect and select airborne targets and calculate a lead pursuit course for attack with guns or rockets. Speaking of weaponry, armament consisted of 4 20mm Pontiac M39 cannons that were fitted only to the second prototype, although it could also be equipped with a single 20mm 6-barrel M61 Vulcan autocannon. 5 hardpoints could be used to carry a total external load of 10,000 pounds. 4 pylons could be attached to hardpoints, 2 for each wing and 1 in the centerline position for a recessed weapons payload, or an additional fuel tank. Power was provided by a single Pratt & Whitney YJ75P9, which was essentially the bigger brother of the Pratt & Whitney J57 that powered the F-100 Super Sabre. With the afterburner, the J75 produced an incredible 24,500 pounds of thrust. The design of the F-107A allowed for the engine to be removed by undoing a few bolts, making maintenance simpler and faster. The J75 was capable of pushing the F-107A up to 890 miles an hour at sea level and 1,295 miles an hour at 36,000 feet, which it could reach in less than a minute. It could climb at a rate of 39,900 feet per minute with a service ceiling of 53,200 feet. Although the maximum altitude was rated at 53,000 feet, test pilot Al White, while exploring zoom climb characteristics, was able to reach 69,000 feet in the first prototype by starting off at 31,000 feet at Mach 2.1. The max demonstrated Mach number attained was 2.18, although the North American engineers estimated that by increasing the inlet area slightly, the jet was capable of reaching roughly Mach 2.4. Along with this blistering performance, she had a range of 788 miles, but could cover 2,428 miles with additional fuel carried in a recessed centerline external tank and in drop tanks suspended from wing hardpoints. By 1956, North American had built 3 F-107A prototypes that underwent expensive ground testing with full afterburners before the first prototype took to the air from Edwards Air Force Base on September 10, 1956, with company test pilot Bob Baker at the controls. During her first flight, which lasted 43 minutes, Bob Baker took the jet supersonic, reaching Mach 1.03. However, on landing, the brake chute failed to deploy, causing the jet to come in hot, and overrun the end of the concrete runway and ended up in a ditch. The aircraft was quickly repaired, however, and flew again 3 days later, with the same F-107A going on to break Mach 2.0 2 months later, on November 3, 1956. The third prototype, fitted with a fully automatic variable area inlet duct, flew for the first time in December 1956. Unfortunately, the variable geometry duct did not live up to expectations. In spite of repeated attempts at steady climbs at subsonic or supersonic speeds, and even zoom climbs for maximum speeds at 35,000 feet, the jet was never able to get above 51,000 feet. This was blamed on problems with the variable geometry intake duct and with the J75 engine, both of which were relatively new at the time. In addition, there was an annoying buzz in the variable air intake at high speeds, which was traced to the instability of the airflow at the inlet. Despite this, the trio of F-107A aircraft flew 272 flight tests, totaling 176.5 hours. During the development of the F-107A, the U.S. Air Force also experimented with adding a zero-length, or ZEL, launch capability to several of its fighter designs, including the Republic F-84 and F-100, while the German Air Force tested ZEL launchers with the Lockheed F-104 Starfighter. The primary benefit of ZEL launching a fighter aircraft is that it removes the necessity of using a hard surface runway, keeping the vehicle mobile and difficult to locate. The relative simplicity of placing a large rocket beneath a fighter attached to a launch platform that could be placed anywhere was of keen interest to Air Force brass. North American Aviation claimed that zero-length launching capabilities could easily be added to the F-107A by making simple modifications to the fuselage to attach a rocket booster. Thus, launching the jet directly into flight would give the Air Force a tactical advantage over having to depend on hard-surfaced runways, meaning that the F-107A could be launched from either hardened or mobile launching sites. The idea was to use the X-226A booster being manufactured for the Snark missile, which was capable of 132,000 pounds of thrust and could launch an F-107A weighing up to 49,000 pounds. An F-107A could be prepared for a launch in less than 10 minutes. During this time, the pilot enters the cockpit and starts the engine. The jet is raised nose up to the launch position, where, when ready, the rocket booster ignites, and the F-107A is fired into the air like a dart. Once the rocket fuel is expended, the booster and frame attachment is released, and the F-107A continues on its mission under its own jet power. During the test program, the 107 was in direct competition with the Republic F-105 Thunderchief for production orders. Tactical Air Command decided to hold a fly-off between the 107 and 105, which were designed for the same mission, used the same J-75 engine, and like the F-107A, had variable geometry inlet, allowing the Thunderchief to reach Mach 2. Everyone at Republic Aviation expected the F-107A to win the USAF contract, and was hoping that they might get a subcontract from the USAF to manufacture it. However, after many months of discussions, the Air Force selected the F-105 Thunderchief, ending the F-107A development contract. The F-105 saw service in Vietnam, where it flew over 20,000 sorties, but was pulled from combat duty because nearly half of the 833 Thunderchiefs built were shot down, with 382 aircraft lost, including 62 operational non-combat losses, the only American aircraft to have been removed from combat due to high loss rates. The origins of the F-105 nickname Thud are obscure. Some claim that it stood for the sound of an F-105 crashing into the ground. Even so, it was still a capable platform in expert hands, and although less agile than the smaller MiG fighters, they did manage to be credited with 27.5 kills. At the time the office of the Secretary of the Air Force made that decision, the F-105 had flown for a handful of hours, and had already exhibited, in the words of Air Force test pilot Melbourne Mel Apt, more deficiencies than are normally encountered in other aircraft at a similar stage of development. Even so, the F-105 had an internal bomb bay, which Tactical Air Command loved. It wasn't sort of a bomber, it was a bomber, and could carry 14,000 pounds of ordnance, which was 40% more than the F-107A, and it was therefore considered a better bomb truck, and the ability to put ordnance on target is paramount in a tactical aircraft. And the Thunderchief could deliver the goods. Even though I would consider the Ultra Sabre to be the better aircraft, the Thunderchief better met the requirements as a nuke and conventional strike ground attack warplane. To this day, many say that the reason the F-105 was chosen over the F-107A had more to do with the state of affairs at the two competing companies. At the time, Republic Aviation was winding up production of its F-84 series of fighters and had nothing else in the books for the future, and the Air Force may have wanted to find work for Republic and keep it afloat. There were even rumors that half of the flight test report for the F-105 was missing or information altered. Nevertheless, North American was busy with the F-100 Super Sabre and follow-on F-86 programs. It was also engaged in development work on several important defense projects, such as the A-5 Vigilante carrier-based nuclear bomber for the Navy, the XB-70 Valkyrie Mach 3 strategic bomber for Strategic Air Command, and the XF-108 Rapier Mach 3 interceptor for Air Defense Command. In the late 1950s, these three projects were expected to be at the forefront of US air power. Unfortunately, no one could foresee that only the Vigilante would ever enter production and become operational. The XB-70 was cancelled in the mid-1960s when it became clear that ballistic missiles constituted a far more effective nuclear deterrent than any manned bomber. The F-108 Rapier, which was intended to replace the Convair F-106 Delta Dart as the North American continent's principal air defense against incoming Soviet supersonic bombers, was also cancelled in 1959, while still in the mock-up stage due to its high cost. The first and third F-107As were turned over to the National Advisory Committee for Aeronautics, or NACA, the predecessor of NASA, for high-speed flight testing work. However, the first prototype was so mechanically unreliable that it was grounded by NACA after only 4 flights and was scavenged for spare parts to keep the other one flying. The third prototype was damaged when test pilot Scott Crossfield was forced to abort a takeoff because of control problems. Both tires blew and the left brake burst into flames. Crossfield was uninjured, but the resulting damage to the F-107A was deemed to be too severe for economical repair, and NASA decided to scrap the aircraft. It was cut up and its fuselage shipped to Shepherd AFB in Texas, where it was eventually destroyed during firefighting training around 61 or 62. Though it never became a production aircraft, the F-107A contributed in significant ways to aviation progress. Indeed, many future aircraft would greatly benefit from F-107A flight control and air induction technology, including the A-5 Vigilante, XB-70, A-12, SR-71, YF-12A, and F-15. Only 2 of the 3 F-107As built survive. The number 1 F-107A is displayed at the Pima Air and Space Museum in Tucson, Arizona. The number 2 ship resides at the Wright-Patterson National Museum of the U.S. Air Force in Dayton, Ohio, although at the time of recording this video, the jet is in storage. Now before you ask, no pilot was ever sucked into the air intake during an injection, and was sadly the last fighter aircraft to come from the North American Aviation stable before the company merged with Rockwell in 1967 and then swallowed up by Boeing in 1996. Thank you for watching my video. Please like and subscribe to find more exciting historical content, and let me know in the comments below what you think of the F-107A Ultra Sabre. Did the prototype have a chance against the Republic F-105 Thunderchief?